Hey everyone, welcome back to our channel. If you're new here, don't forget to hit that subscribe button and the bell icon so you won't miss our future videos. Today's video is going to be super informative, especially if you're preparing for a PySpark interview. We've compiled a list of the most commonly asked PySpark questions, along with detailed answers and examples to help you understand each concept thoroughly. Let's get started. What is PySpark?
PySpark is the Python API for Apache Spark, a fast and general-purpose cluster computing system. PySpark provides easy-to-use APIs for handling large-scale data processing tasks by distributing computations across a cluster of machines. In this example, we import the necessary modules, create a Spark session, create a data frame with some data, and display it. This demonstrates the basic workflow of PySpark programming.
What are the different ways to create a data frame in PySpark?
There are several ways to create a data frame in PySpark. 1. From an existing RDD using the toDF method. 2. From a list or a collection of row objects. 3. From a pandas data frame. 4. From an external data source such as CSV, JSON, or Parquet files. 5. From an existing data frame by applying transformations or aggregations.
What is RDD in PySpark?
RDD, Resilient Distributed Data Set, is the fundamental data structure in PySpark, representing an immutable distributed collection of objects that can be processed in parallel across a cluster. In this example, we create an RDD from a list of integers using scparallelize. Then, we apply a transformation using the map function to double each element. Finally, we collect the results using the collect action, which returns the transformed RDD's elements as a list.
What is data frame in PySpark?
Data frame is a distributed collection of data organized into named columns, similar to a table in a relational database. It is designed to make large-scale data processing easier and more accessible, providing functionalities similar to SQL. This example creates a data frame from a list of tuples representing name and age pairs. We specify the column names using the schema parameter and create data frame. Finally, we display the data frame using the show function.
What are transformations and actions in PySpark?
Transformations are operations that are lazily evaluated and return a new RDD or data frame, such as map, filter, and reduce by key. Actions are operations that trigger the execution of transformations to return a result to the driver program, such as collect, count, and save as text file. In this example, map is a transformation that doubles each element in the RDD. Collect is an action that triggers the execution of the map transformation and returns the results to the driver program.
What is lazy evaluation in PySpark?
Lazy evaluation means that transformations on RDDs or data frames are not immediately computed. Instead, they are recorded as a lineage of operations to be executed when an action is called. This allows for optimizations like pipelining and avoiding unnecessary computations. In this example, the map transformation is defined on the RDD, but no computation occurs until the collect action is called, triggering the execution of the transformations.
What is the difference between persist and cache in PySpark?
Both persist and cache are used to persist the RDD or data frame in memory for faster access. The difference is that persist allows you to specify storage levels, e.g., memory only, memory and disk, whereas cache defaults to memory only. In this example, persist is called on an RDD without specifying a storage level, so it defaults to memory only. Cache is called on a data frame, also defaulting to memory-only storage level.
What is the significance of a partition in PySpark?
A partition is a logical division of data in an RDD or data frame that determines how the data is distributed across the nodes in a cluster for parallel processing. Optimizing the number of partitions can improve performance by balancing workload and reducing data shuffling. In this example, we create an RDD with 5 elements and specify 3 partitions using the number slices parameter. We then get the number of partitions using the getNumberPartitions method.
How does Spark handle fault tolerance?
Spark handles fault tolerance through RDD lineage and resilient distributed datasets. RDDs keep track of the transformations applied to the base dataset, allowing lost data partitions to be recomputed from the original data source. RDDs also store lineage information to reconstruct lost data partitions in case of failures. In this example, we apply a transformation to an RDD and simulate data loss in a partition using a filter transformation. The lost data partition is recomputed from the original RDD using RDD lineage information.
What are the different types of joins in PySpark?
PySpark supports several types of joins, including inner join, outer join, left outer join, right outer join, full outer join, left semi-join, left anti-join, natural join, and cross join. In this example, we have 2 data frames df1 and df2 with a common column name. We perform an inner join on the name column, resulting in a data frame containing rows where the name column exists in both data frames.
What is broadcast variable in PySpark?
A broadcast variable is a read-only variable cached on each machine in the cluster rather than shipping a copy of it with tasks. It is used to efficiently distribute large read-only datasets to all the worker nodes in a Spark application.
How can you handle missing or null values in PySpark?
Missing or null values can be handled in PySpark using functions like na.drop to drop rows with null values, na.fill to replace null values with a specified value, or fillna to fill null values with a specified value for specific columns.
What is the purpose of accumulator in PySpark?
An accumulator is a shared variable that allows aggregation of values from worker nodes back to the driver program. It is typically used for counters or summing up values across tasks.
What is the significance of shuffle in PySpark?
Shuffle is the process of redistributing data across partitions in a distributed system. It is necessary for operations like group by, sort by, and join, which require data from multiple partitions to be grouped or sorted together. In this example, we create an RDD with key-value pairs and perform a group-by-key operation, which triggers a shuffle. We then get the number of partitions after the shuffle operation.
How can you optimize PySpark jobs for better performance?
PySpark jobs can be optimized for better performance by tuning configurations like the number of partitions, memory settings, and parallelism levels, using efficient transformations and actions, caching or persisting intermediate results, leveraging broadcast variables and accumulators, and minimizing data shuffling.
How can you handle skewed data in PySpark?
Skewed data can be handled in PySpark by using techniques like data skew detection, partitioning based on skew keys, using salting or hashing, performing manual repartitioning, or using specialized functions like repartition by expr or bucket by.
What is the purpose of UDF, user-defined function, in PySpark?
UDF allows you to define custom functions in Python and apply them to data frame columns in PySpark. It provides flexibility to perform complex operations that are not available in built-in Spark SQL functions.
What are window functions in PySpark?
Window functions in PySpark allow you to perform calculations across a set of rows related to the current row, such as calculating moving averages, cumulative sums, or ranking rows within a partition.
What is the difference between map and flat map in PySpark?
Both map and flat map are transformation functions in PySpark. Map applies a function to each element of an RDD or data frame and returns a new RDD or data frame, while flat map applies a function that returns an iterator to each element and flattens the result into a single RDD or data frame. In this example, map applies a function that returns a list to each element, resulting in an RDD of lists. Flat map applies a function that returns a list to each element, but flattens the result into a single RDD.
What is the purpose of DataFrame API in PySpark?
The DataFrame API in PySpark provides a higher-level abstraction for working with structured data compared to RDDs. It allows users to perform SQL-like operations, including filtering, grouping, aggregating, and joining data, with a more concise and user-friendly syntax. In this example, we create a data frame from a list of tuples representing name and age pairs and display the data frame using the show function.
What are the benefits of using PySpark for big data processing?
PySpark provides several benefits for big data processing, including scalability for processing large data sets, fault tolerance for handling failures, high-level APIs for productivity and ease of use, integration with other big data technologies like Hadoop and Hive, and support for multiple programming languages like Python, Java, and Scala.
What is the role of the driver and executor in PySpark?
In PySpark, the driver is responsible for orchestrating the execution of the Spark application, including translating user code into tasks and managing the execution flow. Executors are responsible for executing tasks on individual worker nodes in the cluster and storing intermediate data in memory or disk.
What is the purpose of Catalyst Optimizer in PySpark?
The Catalyst Optimizer in PySpark is a query optimizer that optimizes the logical plan of data frame operations to generate an efficient physical execution plan. It performs optimizations like predicate pushdown, column pruning, and join reordering to improve query performance.
How can you read data from external data sources in PySpark?
PySpark provides built-in support for reading data from various external data sources like CSV, JSON, Parquet, Avro, JDBC, ORC, and HDFS. Users can use DataFrame APIs like read.csv, read.json, read.parquet, etc. to read data from these sources.
How can you write data to external data sources in PySpark?
PySpark provides built-in support for writing data to various external data sources like CSV, JSON, Parquet, Avro, JDBC, ORC, and HDFS. Users can use DataFrame APIs like write.csv, write.json, write.parquet, etc. to write data to these sources.
What is the difference between repartition and coalesce in PySpark?
Both repartition and coalesce are used to change the number of partitions in an RDD or data frame. However, repartition shuffles the data across the cluster and can increase or decrease the number of partitions, while coalesce reduces the number of partitions without shuffling, if possible. In this example, repartition is used to change the number of partitions to 2, which involves shuffling the data. Coalesce is used to reduce the number of partitions to 2 without shuffling, if possible.
What is the purpose of the Spark session in PySpark?
Spark session is the entry point to Spark functionality in PySpark. It provides a way to interact with Spark functionality, including creating data frames, executing SQL queries, and managing resources such as memory and course. In this example, we create a Spark session using the builder pattern with an application name, example, and retrieve an existing Spark session if it exists, or create a new one if it doesn't.
What is the role of the Spark context in PySpark?
Spark context is the entry point to Spark functionality in older versions of PySpark, prior to Spark 2.0. It is used to create RDDs, perform transformations and actions, and manage resources such as memory and cores. In Spark 2.0 and later, Spark Session replaces Spark Context for most functionality. In this example, we create a Spark context with an application name example using the Spark context constructor.
What is a Spark job in PySpark?
A Spark job in PySpark consists of a set of transformations and actions applied to RDDs or DataFrames, executed in parallel across a cluster of machines. Each job consists of one or more stages, which are further divided into tasks. In this example, we apply a transformation, map, and an action collect to an RDD, which constitutes a Spark job. The job is divided into stages and tasks, which are executed in parallel across the cluster.
How can you handle skewness in data for joins in PySpark?
Skewness in data for joins in PySpark can be handled by using techniques like salting, broadcasting small tables, or using a combination of techniques such as filtering out skewed keys, performing multiple joins, and then merging the results.
What is the purpose of the cache function in PySpark?
The cache function in PySpark is used to persist the RDD or data frame in memory, allowing faster access to the data for subsequent operations. It is especially useful when the same RDD or data frame is used multiple times in different transformations or actions. In this example, we use the cache function to persist an RDD in memory and then collect the results, demonstrating faster access to the data.
What is the purpose of the unpersist function in PySpark?
The unpersist function in PySpark is used to remove the RDD or data frame from memory cache, freeing up memory resources. It is useful for releasing memory occupied by cache data that is no longer needed. In this example, we first cache an RDD in memory, collect the results, and then unpersist the RDD to release the memory resources.
What is the purpose of the take function in PySpark?
The take function in PySpark is used to retrieve the first in elements from an RDD or data frame. It is commonly used to inspect the data or retrieve a small sample for analysis. In this example, we use the take function to retrieve the first 3 elements from an RDD.
What is the purpose of the collect function in PySpark?
The collect function in PySpark is used to retrieve all elements from an RDD or data frame and bring them back to the driver program. It should be used with caution as it can potentially collect a large amount of data and overwhelm the driver's memory. In this example, we use the collect function to retrieve all elements from an RDD and print the result.
What is the purpose of the count function in PySpark?
The count function in PySpark is used to count the number of elements in an RDD or data frame. It is a transformation that triggers the execution of the job and returns the count as an integer. In this example, we use the count function to count the number of elements in an RDD.
What is the purpose of the filter function in PySpark?
The filter function in PySpark is used to apply a predicate function to each element of an RDD or data frame and return a new RDD or data frame containing only the elements that satisfy the predicate. In this example, we use the filter function to filter out even numbers from an RDD.
What is the purpose of the map function in PySpark?
The map function in PySpark is used to apply a function to each element of an RDD or data frame and return a new RDD or data frame containing the results of the function applied to each element. In this example, we use the map function to double each element of an RDD.
What is the purpose of the reduce function in PySpark?
The reduce function in PySpark is used to aggregate the elements of an RDD or data frame using a commutative and associative binary operator function. It repeatedly applies the function to pairs of elements until only a single result remains. In this example, we use the reduce function to calculate the sum of elements in an RDD.
What is the purpose of the group by function in PySpark?
The group by function in PySpark is used to group the elements of an RDD or data frame based on a key function and return a new RDD or data frame where each element is a tuple containing a key and an iterator of the grouped elements. In this example, we use the group by function to group elements of an RDD by their first component.
What is the purpose of the join function in PySpark?
The join function in PySpark is used to join two RDDs or data frames based on a common key and return a new RDD or data frame containing pairs of elements with matching keys. In this example, we use the join function to join two RDDs based on their first components.
What is the purpose of the sort by function in PySpark?
The sort by function in PySpark is used to sort the elements of an RDD or data frame based on a key function and return a new RDD or data frame with the elements sorted in ascending or descending order. In this example, we use the sort by function to sort the elements of an RDD in ascending order.
What is the purpose of the distinct function in PySpark?
The distinct function in PySpark is used to remove duplicate elements from an RDD or data frame and return a new RDD or data frame containing only unique elements. In this example, we use the distinct function to remove duplicate elements from an RDD.
What is the purpose of the sample function in PySpark?
The sample function in PySpark is used to create a random sample of elements from an RDD or data frame with or without replacement and return a new RDD or data frame containing the sampled elements. In this example, we use the sample function to create a random sample of elements from an RDD without replacement.
What is the purpose of the takeSample function in PySpark?
The takeSample function in PySpark is used to create a random sample of elements from an RDD or data frame with or without replacement and return a list containing the sampled elements. In this example, we use the takeSample function to create a random sample of elements from an RDD without replacement and retrieve the sampled elements as a list.
What is the purpose of the forEach function in PySpark?
The forEach function in PySpark is used to apply a function to each element of an RDD or data frame without returning a result. It is typically used for side-effecting operations such as writing to external storage or updating shared variables. In this example, we use the forEach function to print each element of an RDD.
What is the purpose of the toDef function in PySpark?
The toDef function in PySpark is used to convert an RDD containing tuples or lists into a data frame, where each tuple or list corresponds to a row in the data frame and each element corresponds to a column. In this example, we use the toDef function to convert an RDD containing tuples into a data frame with columns, ID, and value.
What is the purpose of the toJSON function in PySpark?
The toJSON function in PySpark is used to convert an RDD or data frame into a JSON string representation, where each element of the RDD or row of the data frame is converted into a JSON object. In this example, we use the toJSON function to convert an RDD containing tuples into a JSON string representation.
What is the purpose of the printSchema function in PySpark?
The printSchema function in PySpark is used to print the schema of a data frame, which includes the data types and nullable properties of each column. In this example, we use the print schema function to print the schema of a data frame containing name and age columns.
What is the purpose of the write function in PySpark?
The write function in PySpark is used to write the contents of a data frame to an external data source such as Parquet, JSON, CSV, JDBC, etc. It allows users to specify various options such as the file format, mode, partitioning, and compression. In this example, we use the write function to write the contents of a data frame to a Parquet file with overwrite mode.
What is the purpose of the readStream function in PySpark?
The readStream function in PySpark is used to create a streaming data frame from a streaming source such as Kafka, HDFS, file system, etc. It allows users to specify various options such as the source type, schema, and options specific to the streaming source. In this example, we use the readStream function to create a streaming data frame from a Kafka topic.
What is the purpose of the first function in PySpark?
The first function in PySpark is used to retrieve the first element from an RDD or data frame and return it as a single element. In this example, we use the first function to retrieve the first element from an RDD.
What is the purpose of the collectAsMap function in PySpark?
The collectAsMap function in PySpark is used to collect the elements of an RDD containing key-value pairs into a dictionary, map, where keys are unique. In this example, we use the collectAsMap function to collect key-value pairs from an RDD into a dictionary.
What is the purpose of the reduceByKey function in PySpark?
The reduceByKey function in PySpark is used to aggregate values of an RDD or data frame with the same key using a commutative and associative binary operator function and return a new RDD or data frame containing unique keys and their aggregated values. In this example, we use the reduceByKey function to aggregate values of an RDD with the same key by calculating their sum.
What is the purpose of the aggregateByKey function in PySpark?
The aggregateByKey function in PySpark is used to aggregate values of an RDD or data frame with the same key using a zero value, a merge function, and a combine function, and return a new RDD or data frame containing unique keys and their aggregated values. In this example, we use the aggregateByKey function to calculate the average value for each key in an RDD.
What is the purpose of the sortByKey function in PySpark?
The sortByKey function in PySpark is used to sort key-value pairs of an RDD or data frame based on the keys and return a new RDD or data frame with the elements sorted by key. In this example, we use the sortByKey function to sort key-value pairs of an RDD by key.
That wraps up today's video. We hope you found it helpful. If you have any questions or topics you'd like us to cover in future videos, let us know in the comments below. Thanks for watching, and we'll see you in the next one.